Hello, welcome to my channel. I am Ameya and we are discussing about control systems in which we have already discussed about S-plane in the previous video. Let us understand the importance of S-plane and how it can be used to understand behavior and performance of your system. Okay, so let us take an example of first order system 1 upon say g of s is equal to 1 upon 1 plus 0.5 s. So what is the pole value for this? You can easily find the pole value for this system by equating this with 0 and finding s. So you will get denominator equal to 0 for the values of s is equal to minus 2. So minus 2 is your pole value. Poles will be represented on your S plane as my cross. Okay, so let us take one more system to compare. I have 1 upon 1 plus zero point 0.2 s, which is having a pole value of minus 5. S is equal to minus 5, and that can be represented here. So this is my first system and this is my second system. Now we can easily understand, as my tau becomes 0, this is the tau, right? 0.5 is my tau. As my tau becomes 0 or tau becomes lesser, we already understood that our system is going to be faster. Okay, and that is what it represents on your S plane. As you reduce your tau, your system keeps on moving towards the left hand side, sorry. And as your system moves left hand side, system becomes more faster. This applies for the second order system or any system. If your poles and zeros are moving away from your origin, you can say that system is going to be performed faster than compared to system which is closer to the origin. Okay, so that is the first thing, how the orientation or location of your poles and zeros will directly reflect into faster and slower system. As we go towards the origin, system becomes slow response, and as we go away from the origin, system becomes faster. Okay, now let us understand how these poles and zero values will directly give you or talk about various time response specifications. So let us say I am having a pole here and I am plotting that pole on my S plane. Okay, so if I try to draw a line between this pole, a straight line from this pole or this origin, sorry, let us say from this origin to this, just move it to pole. So if I try to draw this line will give me lot of values regarding our time response specification. So let us understand that this x factor of this pole gives you minus zeta omega n for the time response specification. So this basically reflects directly into your TP. So if I change my value of pole at different point, you can easily find TP from this just by on a graph. This horizontal or vertical represents your omega d, which is omega n under root 1 minus zeta square. So this vertical value represents omega d. This will also reflect into finding your, sorry, this is for TS, this is for TP and TR. So this will be helpful for finding TP and TR. As I go above, your TP and TR is going to increase, and as I go towards this, your system response, the denominator of your TS is going to be larger. That means TS system is going to be faster. So it reflects the same thing which we have discussing earlier. As we go on the left hand side, system is going to be faster. Now this straight line which I am using to draw between this pole and 0 represents the omega n. Okay, so as the length of the line increases, your omega n will increase. Okay, so you can easily calculate omega n just by plotting a pole and measuring 0 with the length of a line that will reflect into omega n. Now what about zeta? Where you will find zeta? You will find zeta with this angle. This angle this pole is making with origin, that is phi, and the formula for that is cos of phi will be equal to zeta. Okay, so once you plot this line, you can easily measure a value of phi, take the cos of it, you will directly get the value of zeta. Okay, so this is how the everything can be represented on your S-plane, and you can easily determine various values just by plotting a pole on your S-plane. So how this is important? If you want to add any pole or zero in your system, you can add or add and remove poles and zeros from your system depending upon these values, and understanding these values, which basically represents all the values of your zeta and omega n and the time response specification. One more thing I want to discuss here, what if my zeta is going to be smaller, that is 0. What is cos phi 0? It is 90. So as my zeta goes to 0, my system goes towards the y-axis, which is basically no damping. Okay, so as zeta is smaller, my system moves, or this pole moves towards the vertical axis, which is omega d, and that is perfectly fine. That is basically giving me the damping value, no damping value in my system. And as my zeta goes greater, which is zeta going to be greater, I am moving towards 0, and at zeta is equal to 1 I am getting critically damped system, and at zeta is equal to 1 you will get pole or 0 value perfectly on your x-axis. That means if you have any poles and zeros on only on x-axis, that system can be critically damped. Okay, so this value of zeta will also affect your system, so you can place these poles and zeros depending upon your value of zeta. If I am moving closer to imaginary axis, my zeta is smaller. If I am moving closer to real axis, my zeta is going to be larger. Okay, so this is how your S-plane will directly reflect into various factors which we will understand, and then we try to design various factors or implement various control systems for that design. Okay, so this is what I want to discuss in this video about the importance of S-plane and how it directly affects your behavior, or how you can easily predict behavior and performance of your system using just the values of poles and zeros on your S-plane. If you like this content, do subscribe my channel, share it with your friends, and do check the playlists which are available on my channel about control systems, mechanical measurements, and industrial automation. Thank you for joining.